Hi everyone. In this session, we will solve selected problems on differential calculus. So let's begin. First problem is let w is equal to fxy where x and y are functions of t. Then according to the chain rule, dw by dt is equal to. See, formula for a total derivative is a direct result of the chain rule. And I had made a mistake here in the last lecture. Okay, so the correct formula for total derivative is du by dt is equal to del u by del x into dx by dt plus del u by del y dy by dt. So where del u by del x and del u by del y are partial derivatives of u. Yes. So total derivatives are often used in related rates problem. For example, finding the rate of change of volume when two parameters are changing with time. Let us see one example. So first here in this question, correct answer is C. Okay. So now let us see an example. So if the radius and height of a cylinder both are given as 2 centimeter, okay, and the radius is decreased at 1 centimeter per second and height is increasing at at 2 centimeter per second. So what is the change in volume with respect to time at this instant? So see, two parameters are changing with time, radius and height. So we can use this formula of total derivative, and we know the volume of a right circular cylinder is pi r square h, where r is the radius, h is the height. So we take the total derivative of this with respect to time to get dv by dt is equal to del v by del r dr by dt plus del v by del h dh by dt, right? And del v by del r will be 2 pi rh, assuming h as constant, 2 pi rh, and dr by dt is given as 1 centimeter per second plus del v by del h is pi r square, assuming r as constant, and dh by dt is 2 centimeter. Yes, 2 centimeter per second. So now put the value of r and h, 2 centimeter and 2 centimeter. So 8 pi. Yes. Okay, see, dr by dt is minus because it is decreasing. So minus 1 because it is decreasing and height is increasing, so plus 2. So minus 8 pi plus 4 and 8 pi again, and this is 0. Yes. So that means volume is, even though radius is decreasing and height is increasing at 2 centimeter per second rate, but overall volume is not at all changing with respect to time. That means, okay. So this is one example how to use the formula for a total derivative, okay, when two parameters are changing with time. Fine. Okay, so and if u be a function of x and y, where y is a function of x, okay, u is function of xy, where y is the function of x, then du by dx is given as del u by del x plus del u by del y into dy by dx. Okay. So for example, suppose fxy is given as xy, u is given as xy, and rate of change of f with respect to x is the partial derivative of f with respect to x. So del f by del x will be take u, del u by del x is y, and del u by del y is x. Yes. And now let us suppose y is a function of fx, which is y is a function of x. So let us say we have y is equal to x, then so fxy becomes x square. Now du by dx is 2x. Okay. So instead of substituting for y in terms of x, this can be found equivalently using this chain rule. Okay, so du by dx is equal to del u by del x, which is y, plus del u by del y, which is x, and dy by dx, so which is 1. Yes, so dy by dx is equal to 1 from y is equal to x. So which is, now put the value of y in x, which is x plus x, 2x. Okay, so from the chain rule we have got the same answer. Yes, so notice that du by dx is not equal to del u by del x. Okay, so 2x is not equal to y. Okay, yes. And there is one more. If x and y are connected by an equation of the form fxy is equal to 0, then dy by dx is equal to minus del f by del x by del f by del y. Right? Okay, let's go to the next problem. So this is the problem on limit. The value of limit x tends to infinity 1 plus x square e raised to the power minus x is. Okay, so what we can do here is, let us assume y is equal to limit x tends to infinity 1 plus x square e power minus x. Okay, now Let us take logarithm on both sides. So log y is equal to limit x tends to infinity log 1 plus x square e raised to the power minus x, right? Now we can take this in the denominator, e power x, yes, see actually it was e raised to the power minus x. So now from the property of logarithm we have e power minus x log 1 plus x square. Okay, now we can take this in the denominator, so e power x, right? Now if you put x is equal to infinite, so now this is in the form infinity by infinity. Okay, if you put infinity in the place of x, so this is in the form infinite by infinite. So now you can apply L'Hospital's rule. So log y is equal to limit x tends to infinite log x is 1 by x, so 1 by 1 plus x square, and differentiate to x square, so that is 2x by, and differentiating ex, e raised to the power x, ex only. Now so again this can be taken in the denominator, so 1 by 1 plus x square. So again if you put x is equal to infinite, again this is in the form we are getting infinite by infinite, so again apply L'Hospital's rule. So limit x tends to infinite 2 by, now this is in the u into v form, so 1 plus x square ex, now ex and 2x. Okay, so this is again if you put x is equal to infinite, then this becomes 2 by infinite which is 0, so log y is 0. Okay, then y will be equal to 1. Say if this is, base is e, then e power 0 is 1, y is equal to e power 0, that is 1. Okay, so 1 is the answer, right? Next problem is the right circular cone of largest volume that can be enclosed by a sphere of 1 meter radius has a height of, yes, so volume of cone, right circular cone is 1 by 3 pi r square h. So since we have to find the largest volume, so we will be applying the concept of method of maxima and minima. So what was the method of finding maxima or minima of fx? First find f dash x and f double dash x for a given function y is equal to fx. Then second step was equate f dash x to 0 to obtain a stationary point. Yes. And then calculate f double dash x at each stationary point. So, and then we obtain the three conditions. First is f double dash a, if we take a stationary point as a. So f double dash a is greater than 0, then fx has a if f double dash a is greater than 0, that means we have a minimum at x is equal to a, and minimum value will be fa. And if f double dash a is less than 0, then we will have maximum at x is equal to a, and maximum value will be f of a. And if f double dash a is 0, we may not have a maxima or a minima at x is equal to a. Now the calculation part. Let us draw a sphere and let us draw a such cone enclosed by a sphere. Okay. With radius r, yes, and radius of the sphere is given as 1 meter, and we have taken small r. The radius of the base of his cone, this is given as 1 meter, yes, and this is also 1 meter. And let's say the total height is h, so this will be h minus 1. Okay, now V is equal to, volume is equal to 1 by 3 pi r square h. Okay, now from Pythagoras theorem we can write, we can write this r in terms of h. So r square plus h minus 1 square, since square is equal to 1 square, so r square is equal to 1 minus h minus 1 whole square. Okay, so now we can put this value of r square. So we can replace this value of r square here. So V is equal to 1 by 3 pi h 1 minus h minus 1 whole square. Yes. Now this will be equal to 2h minus h square if you simplify, right? And okay, see, there is one more h here. So then this will be equal to pi by 3 2h square minus h cube. Then let us say this is a function f pi by 3 2h square minus h cube. Then find out first derivative of f. with respect to h, which will be pi by 3, 4h minus 3h square, and double derivative will be equal to pi by 3, 4 minus 6h. Okay, now put f dash h is equal to 0, which gives value of h as 0. So 4h minus 3h square is equal to 0. So h 4 minus 3h is equal to 0. So h is equal to 0 and 4 by 3. Yes, the stationary points are 0 and 4 by 3. Now check the value of f double dash h at h is equal to 0. So this is at h is equal to 0, this is positive. F double dash 0 is positive, and at h is equal to 4 by 3, at h is equal to 4 by 3, f double dash 4 by 3 is, if you put 4 by 3, then this is 4 minus 8, which will be negative. Okay, so this is negative. That means fh is maximum at h is equal to 4 by 3. So what was the question? Largest volume that can be enclosed by a sphere of radius has height of. So the largest volume of right circular cone which will fit in a sphere of radius 1 meter will have a height of h is equal to 4 by 3. So 4 by 3 is the right answer. Okay. Next question is, by a change of variable x uv is equal to uv, y uv is equal to v by u is double integral, the integrand fxy changes to, okay, then phi uv is, okay, this is a Jacobian function. Okay, this is from integral calculus, but still let's solve this. So if we have double integral x phi dx dy is equal to f of, so this is equal to f of uv v by u phi uv du dv, where phi uv is Jacobian function. Okay, so J is given as del xy by del uv is equal to determinant del x by del u del x by del v del y by del u del y by del v. So we have x uv as uv, y uv is v by u. So let's differentiate. So x with respect to u will be v, and x with respect to v will be u, right? And y with respect to u will be minus v by u square, okay, keeping v as constant, and differentiating y with respect to v is equal to 1 by u. So now let's put the value. respective values here in the determinant. So vu minus v by u square 1 by u, and this is v by u minus of minus vu by u square. So that is 2v by u. Okay, 2v by u. Here answer is 2u by b. Okay, there must be some printing mistake. Answer is 2v by u only. Okay, 2v by u. Right? Which one of the following functions is strictly bounded? So we have 1 by x square e by a e power x square e power minus x square. So plot of A is as shown, right? Plot of B exponential function is okay like this, and plot of C y is equal to x square is concave upward, and y is equal to e power minus x square is concave downward, right? So being bounded means whose values are bounded, meaning range set of output is finite. For example, sin x function is bounded between +1 and -1. Yes. So you see, only D looks bounded. Okay, so D is the answer, right? For real x, the maximum value of e sin x, e raised to the power sin x by e power cos x is. Okay, so you can write this as e power sin x minus cos x, and we can multiply cos pi by 4 minus cos x sin pi by 4 into √2. Why? Because cos pi by 4 and sin pi by 4 both are is equal to 1 by √2. So if you take out 1 by √2 common, so √2 will get cancelled. So we will again get this result, right? So now this is in the form of sin A minus B, which is sin A cos B minus cos A sin B. If you remember the formula, so now this can be rewritten as sin A cos B minus cos A sin B. So this equation can be rewritten as √2 sin x minus pi by 4. Yes. And original problem was, so let's say this is y is equal to e power sin x minus cos x So we can replace this with this. So we have e root 2 sine x minus pi by 4. For y to be maximum, this should be maximum. And this is maximum. This result is maximum when sine function is maximum, which is plus 1. Since sine function is bounded in between plus 1 and minus 1, so y is maximum at sine x minus pi by 4 is equal to 1 plus 1. Since sine function takes value anywhere in between plus 1 and minus 1, so maximum value of y is e raised to the power root 2 into 1, that is e raised to the power root 2. So C is the right answer. Let's go to the next problem. So consider the function fx where x is real, then the function fx at x is equal to 0 is. Okay, so continuous but not differentiable, once differentiable but not twice, twice differentiable but not thrice, thrice differentiable. Okay. Okay, so let us check the differentiability first. So first order differentiation, okay, of, okay, let us first define fx. So fx is plus x cube when x is greater than 0, minus x cube when x is less than 0, yes, and is equal to 0 at x is equal to 0. Okay, now first order differentiation, this is 3x square when x is greater than 0 and 0 and minus 3x square at x less than 0 and 0 at x is equal to 0. Okay, so at 0 left hand differentiability is equal to right hand differentiability. Yes, because 3 into 0 or minus 3 into 0 is 0. Let us check the double second order differentiability. So this is plus 6x at x greater than 0, minus 6x at x less than 0 and 0 at x is equal to 0. Here if you put x is equal to 0, so this is again 0, so again left hand differentiability is equal to right hand differentiability, so this is again differentiable. Let us take third order differentiation, which is plus 6 at x greater than 0, minus 6 at x less than 0 and 0 at x is equal to 0. See, now left hand differentiability, which is minus 6, and right hand differentiability, which is plus 6. As x approaches 0 from the left, it is minus 6, which is not equal to right hand differentiability, which is plus 6. So third order differentiation is not defined. That means this. So that means this function is twice differentiable but not thrice. Yes. So C is the right answer. And if you have to comment on continuity, So let us look at the plot of this function, modulus of x cube. So this will be like this. So obviously which is continuous at x is equal to 0. Okay, so the function is continuous and twice differentiable but not thrice. Okay, so C is the right answer. So next problem is, in the Taylor series expansion of exponential x plus sin x about the point x is equal to pi, the coefficient of x minus pi whole square is. Okay. So we wish to expand about x is equal to pi, and if you remember Taylor's series expansion about x is equal to a, which is fx is equal to fa plus x minus a f dash a plus x minus a whole square by 2 factorial f double dash a and so on. Okay. Now about x is equal to pi, fx will be, replace a by pi, so f of pi is equal to x minus pi, sorry, this is plus f of pi plus f of x minus pi f dash of pi plus x minus pi whole square by 2 factorial f double dash pi yes. So we have to find the coefficient of x minus pi whole square. Yes. Now, so you see the coefficient of x minus pi whole square is nothing but f double dash pi by 2 factorial. So now let us differentiate f of x, which is ex exponential x plus sin x. So f dash x is equal to ex and sin x, so it will be cos x. Again f double dash x will be e raised to the power x minus sin x. Okay, so now put x is equal to pi, so f double dash pi is equal to e power pi minus sin pi, so sin pi is 0, so we have e raised to the power pi as the coefficient. Okay, so B is the answer because e raised to the power by 2 factorial. Exponential pi by 2, that is 0.5 times exponential pi, right? Let's go to the next problem. Okay, the length of the curve y is equal to 2 by 3 x raised to the power 3 by 2 between x is equal to 0 is. See, the length of the curve is given by root under 1 plus dy by dx whole square dx. Okay, so now find dy by dx first. So dy by dx is equal to, y is given as 2 by 3 x raised to the power 3 by 2. So 2 by 3 3 by 2 x 3 by 2 minus 1, which is root x or x power 1 by 2. So length of the curve, to find out the length of the curve, put dy by dx in the formula. So root under 1 plus, so root x, so x is root x goes whole square, so this is x, okay, dx, and between x is equal to 0 and x is equal to 1, so this is our definite integral 0 to 1. Now find out the integration. So this will be 2 by 3, 1 plus x, 3 by 2, x varies from 0 to 1. Answer will be 1.22. Yes. Right? Next problem. A cubic polynomial with real coefficients can possibly have no extrema and no zero, may have up to 3 extrema and up to 2 zero crossings, cannot have more than 2 extrema and more than 3 zero crossings, will always have an equal number of extrema and zero crossing. See, nth degree polynomial, nth degree polynomial bends exactly n minus 1 times. Okay, and therefore can have a maximum of n minus 1 minima or extrema. Yes. Okay, so and also nth degree polynomial has n roots, and n roots means zero crossings. This number of zero crossings. Yes. So a cubic polynomial of degree 3 cannot have more than 2 extrema and cannot have more than 3 zero crossings. Okay, so answer is C. Cannot have more than 2 extrema and cannot have more than 3 zero crossings. Okay, clear? So next question is limit x tends to 0 sine square x is equal to. So see, this is the problem on limit, and we know that sine x by x, limit x tends to 0 is equal to 1. Yes. So we can modify this problem as, since we have one standard limit, so limit x tends to 0 sine x by x whole square into x, then this will be 1, so 1 square into x, and if you put x is equal to 0, then this will become 0. So now this is 0 is the right answer. Okay, let us go to the next problem. Okay, the distance between the origin and the point nearest to it on the surface z square is equal to 1 plus x y is. Okay. surface is given as z square 1 plus xy is equal to 1 plus xy. So let P x y z is nearest point to this surface. So distance from the origin will be say d is equal to root under x minus 0 square plus y minus 0 square plus z minus 0 whole square. So d square is x square plus y square plus z square. Okay. And if you put z square as 1 plus xy, so d square is equal to x square plus y square plus 1 plus xy. Yes. So now the distance is shortest. The distance is shortest when d is minimum. Okay, so we need to find the minima of this function. Okay. So let's say, so if d is minimum, that means d square is also minimum. So we can take this as a function u and then find the minima of this function. Del u by del x is equal to 2x plus y and del u by del y is equal to 2y plus x, right? Okay, so now put the value, now equate this to 0 and this to 0. So you solve simultaneously, you will get x is equal to 0 and y is equal to 0. So that means x is equal to 0 and y is equal to 0 is the only solution. And so 0, 0 is only the stationary point. Is the only stationary point. Now let us find r, s and t. R is del square u by del x square, which is equal to 2 and s is equal to del square u by del x del y, which is equal to 1, right? Then t is equal to del square u by del y square, which is equal to 2. So since we have r t is equal to rt minus s square is equal to 2 into 2 4 minus 1, which is positive. Yes. So since r is also positive, so it is a minima at 0, 0. So rt minus s square is positive and r is also positive. So that means we have a minima at 0, 0. So z will be equal to 1 plus root under 1 plus xy, which is 1, and z square is also 1. So the distance is root under 0 square plus 0 square plus 1, that is 1. So the correct answer is 1. Yes. Clear? Okay, let's go to the next problem. Taylor series expansion of sin x by x minus pi at x is equal to pi is. So here, let us put x minus pi as t. X is equal to pi plus t. Yes. So now, you know f of t is equal to so f of t will be equal to sine of pi plus t or t plus pi by t. Okay. So we know that if sine of t plus pi is minus sine t. See? Right? So this is minus sine t by t now. And we know the expansion of sine t. Or you can use Taylor series expansion properly. But since we know the sine t expansion of sine t already, so we can just directly put the values. So this is t minus t cube by 3 factorial plus t power 5 by 5 factorial and so on, minus, right? Then t. Okay, now this is minus 1 minus t square by 3 factorial minus t raised to the power 4 by 5 factorial and so on. Now replace t by x minus pi whole square by 3 factorial plus x minus pi raised to the power 4 by 5 factorial minus. Okay, now take this negative side sign inside, so minus 1 plus x minus pi whole square by 3 factorial minus x minus pi raised to the power 4 by 5 factorial and so on, right? Okay, solved. Now let's go to the next problem. If y e raised to the power y is equal to x raised to the power 1 by x, then y has a. Now taking log on both sides, so e power y is equal to x power 1 by x given. So if we take log on both sides, so y is equal to 1 by x log x. Now let us find out dy by dx, which is 1 by x u into v form, 1 by x again plus log x, and differentiation of 1 by x is minus 1 by x square, so which is 1 by x square 1 minus log x. Okay, now put dy by dx is equal to 0. So you will get log x is equal to 1. That means x is equal to, okay, log x is equal to 1, right? So equating this equal to 0, resulting log x is equal to 1. So x is equal to e. So this is a stationary point. Now let us find out second order derivative. Yes, so 1 by x square into minus 1 by x plus 1 minus log x, and derivative of 1 by x square is minus 2 by x cube. So this is minus 1 by x cube 1 plus 2 1 minus log x. So this is the simplified form. Okay, you can again write this as 3 minus 2 log x. So now this is simplified. Now so since x is equal to e is a stationary point, now put x is equal to e in d square y by dx square. Put x is equal to e, so you will get minus 1 by e cube 3 minus 2 log e. Okay, so log e is 1. Yes, so 3 minus 2 is 1, so this is nothing but minus 1 by e cube, so which is negative because e value of e is 2 point something, 2.7. Okay, so x is equal to e, that means x is equal to e, we have a maximum. At x is equal to e, we have a maximum. So answer is A. Right? So next problem. So the series converges for. So okay, notice the power 2m. So you can make the power of this term as 2m by writing 2 power 2m. Yes. So now summation m is equal to 0 to infinite 1 by 2 power 2m x minus 1 2m. Okay, so now x minus 1, take this inside, x minus 1 2m. Yes, now put the values of m. So first term will be anything to the power 0 is 1 plus x minus 1 by 2 whole square plus x minus 1 by 2 whole to the power 4, and so on, goes up to infinity. So this is a geometric progression. Do you remember? So if it is a geometric progression, then it will converges for r less than 1. Yes. And what is the common ratio? X minus 1 by 2 whole square. So x minus 1 by 2 whole square must be less than 1. And if you solve this, you will get x minus 1 whole square less than 4. Then x minus 1 varies between minus 2 and plus 2. So x will lie in between minus 2 plus 1, 2 plus 1, which is minus 1, and plus 3. So this series will converge for x in between -1 and 3. So B is the right answer. Let us go to the next problem. So if z is given as the value of, okay, so let us rewrite z ax plus by function ax minus by. Now take the partial derivative del z by del x, since we have to find del z by del x and then del z by del y. So this is in the u into v form. Okay, so now ax plus by function ax minus by. Now take the function, now take u as constant. So ax plus by f dash ax minus by and a. Similarly, okay, you have to find b del z by del x. So multiply b del z by del x, you will get a b constant and ax plus by function ax minus by plus ax plus by to function ax minus by. Okay, right? Now del z by del y, we have b ax plus by function ax minus by. Okay, plus ax plus by function ax minus by and into minus b. So this will be minus b. So now take b outside and you have to find a del z by del y. So multiply a. So a del z by del y, you will get ab as common and e raised to the power ax plus by f ax minus by. This is nothing but z. So z minus e raised to the power ax plus by to function ax minus by. Right? Now add both equations. If you add b del z by del x and a del z by del y, see this will get cancelled. Yes, so you will left with 2 a b z. Okay, because this will be cancelled, this second term. So abz plus abz will result in 2abz, 2 times abz. So D is the right answer. Next question, the values of x for which the function fx is not continuous are. So you have to find the points, the values of x at which function is not continuous. So when the function is continuous, if function is continuous, said to be continuous at x is equal to a, if it is defined at x is equal to a, left hand limit is equal to right hand limit is equal to value of the function and is real and finite, then we say that the function is continuous at that point or at the value of x. Okay, and the function is said to be differentiable if at x is equal to a, left hand derivative is equal to right hand derivative and is well defined. So this function is not defined when it tends to infinite value, when it when the value of this is infinite. And when can this function of value can be infinite? When denominator is equal to 0. So when denominator is equal to 0, fx tends to be infinite. So we have to find the values of x for which the denominator becomes 0. So x is square plus 3x minus 4 is equal to 0. You have to find the roots. So this is x plus 4, x minus 1 is equal to 0. So x is equal to 1 and x is equal to minus 4. So that means this function is not continuous at x is equal to 1 and x is equal to minus 4. So C is the right answer. Next question. Let fx is equal to x raised to the power minus 1 by 3. That means 1 by cube root of x. And denote the area of the region bounded by fx and the x-axis. When x varies from minus 1 to plus 1, which of the following statement is true? So we have to find out check the continuity, right? We have to check the continuity at let us check the first statement. So let us check the continuity at x is equal to 0. So left hand limit x tends to 0 minus 1 by cube root of x is nothing but, say, h 0 minus h is limit s tends to 0 minus 1 by root under cube root of h, which is, if you put s equal to 0, it is minus infinite. This value tends to be minus infinite. So right hand limit s tends to 0 plus x tends to 0 plus, or s tends to 0 1 by cube root of 0 plus h is equal to limit s tends to 0 1 by cube root of h, so which is equal to plus infinite. That means left hand limit is not equal to right hand limit. So statement 1 is false. This is false. Now let us check the second statement. F is not bounded in minus 1 and 1. Since x is equal to 0, it goes to minus infinity and plus infinity. The function is not bounded. Yes, at x is equal to 0. Yes, no. Yes, at x is equal to 0, it goes to minus infinity and plus infinity. We just checked. So that means the function is not bounded. So this is also, yes, this is true. Second statement is true. Next, a is non-zero and finite. So for that, you have to check the area. So for area, let us find the integration. Area is equal to x raised to the power minus 1 by 3 dx minus 1 to 0 plus 0 to 1 x raised to the power minus 1 by 3 dx. Right? Okay, now this is 3 by 2 x raised to the power 2 by 3 minus 1 to 0 plus 3 by 2 x raised to the power 2 by 3 0 to 1. So you will get, okay, you have to take the modulus because we are we are finding area. Okay, we have to find area, so that is I modulus. Okay, because area cannot be negative, so that is why I have taken modulus. Means I want the positive value. So 3 by 2 plus 3 by 2, that is 3. So area is non-zero and finite. This is true. So we have 2 and 3 only as the correct statement. Next problem. Limit root under n square plus n minus n square plus 1 root under is. So in order to remove this root and simplify, what we can do is multiply and divide this numerator with n square plus n square plus 1. So multiply and divide n square plus n square plus 1 in the numerator and denominator. So okay, so numerator will be roots will be removed from the numerator, so which is a minus b, a plus b, so a square minus b square, and okay, now yes, limit n tends to infinity. So if you take this, gets cancelled. Okay, so if you take the value, put the value of infinite. So wait, not now. I can take n square. Okay, let us take n square as common. So 1 plus one by n root under plus similarly n square 1 plus 1 by n square. Yes, now so we can take out n out of square root. So 1 n minus 1 by n root under 1 plus 1 by n plus n root under 1 plus 1 by n square. Now put the value of infinity. So if you put the value of infinite, am I wrong somewhere? Okay, n minus 1 can also be written as, if you take out n common, so 1 minus 1 by n. Yes, now we can cancel out n. So now let us put n is equal to infinite, then this value will be 1 minus 0, 1, and this will be 1 plus 1, so that is 1 by 2. Okay, so this is the answer. Now let us go to the next problem. Okay, 1 by 2. The answer is 1 by 2 or 0.5. So next problem. The maximum area of a rectangle whose vertices lies on the ellipse x square plus 4y square is equal to 1. Okay, so let us have a rectangle such as, okay, this is xy axis and this is y, and this is 2x. So this is 2y. So I am taking this for convenience. Y. Okay. Now area of rectangle is 2x into 2y, that is 4xy, and say this is f function, and we are given x square plus 4y square is equal to 1. So since we have terms like x square and y square, let us take f square, which will be 16x square y square. Now so we can replace 4y square with 1 minus s square. So 4x square 1 minus x square, right? Since 1 minus x square is 4y square. Now say this is function f. Okay, let us take this area and this is function. Now let us find the first derivative of x, fx, and equate it to 0. So 4x square is equal to 0. You will get 4 into 2x minus 4x cube is equal to 0. We get x is equal to 0. Sorry, x is equal to, yes, x is equal to 1 root can be 0 or plus minus 1 by root 2. Right? So x is equal to, now for maximum area, obviously x cannot be 0, so we can take this value plus 1 by root 2. Yes, then y will be equal to plus minus 1 by root 8. For x plus minus 1 by root 2, y will be equal to plus minus 1 by root 2. Then area will be 4 into x into y. So 4 into 1 by root 2 into 1 by root 8. Then 4 by root under 16 and you will get 1 as the answer. Okay. So 1 is the right answer. Yes. Okay, let us go to the next problem. See, we did not check here double derivative, means we did not differentiate f double dash x and then put the values of put the stationary points and checked it. Why? Because this is clear from the values itself that 0 cannot be the value to maximize. In order to maximize the area, we cannot take 0, x is equal to 0, and we cannot take minus 1 by root 2 as well. So yes, so that is why the answer was direct. If the sum of diagonal elements of 2 cross 2 symmetric matrix is minus 6, then the maximum possible value of determinant of the matrix is. So consider a symmetric matrix A, P and B, D. Yes. So given A plus D is equal to minus 6. Now since determinant of A is AD minus B square. since b square is always positive, that is non-negative, so maximum determinant will come when b is equal to 0. Then we need to maximize only AD. Okay, we'll take b as 0. Okay, so now d is equal to, from here d is equal to minus 6 plus a, sorry, minus 6 minus a. Now put the value minus 6 minus a, which will be minus 6a minus a square. Now let us maximize this. To maximize, let us find out the derivative with respect to a. So minus 6 minus 2a. Now equate it to 0 to find out the stationary point. So a will be equal to minus 3, which is the only stationary point. Now d square a by dA, we have minus 2, which is always negative. That means we have a maximum at a is equal to minus 3. Since a plus d is equal to minus 6, then corresponding value of d will be equal to minus 6 minus plus 3, which is minus 3. Now the maximum value of determinant is a into d, which is minus 3 into minus 3, which is 9. Yes, so 9 is the right answer. Now let us go to the next problem. The value of limit x square minus xy root x by root x minus root y is. So if you put x and value of x and y, then you will get 0 by 0 form. So here, since there is two variable, you cannot directly use L'Hospital's rule. So with two variable, so what we can do is take one as dependent variable, y is equal to kx. Now work out the problem. X square minus x kx, that is kx square, by root x minus root y, so root x minus root under kx. Now take the value x square outside 1 minus k, and here root x 1 minus root k. Okay. Now take the limit x tends to 0, x 2, okay, minus 1 by 2, 1 minus k by 1 minus root k. Yes, now put the value of x. Now if you put the value of x, so this is 0, you will get the 0. So 0 is the right answer, right? Let us go to the next problem. If u is equal to log x square plus y square by x plus y, what is the value of? So this is the problem on Euler's theorem. So since u is equal to log of x square plus y square by x plus y is non-homogeneous, make this function as homogeneous. Taking antilog on both sides, e raised to the power u is x square plus y square by x plus y. Okay, now this becomes homogeneous. So you can check by putting the value tx for x and ty for y. So this becomes x square plus y square by t x plus y. So now this function is homogeneous of degree n, degree 1. Okay. So now So which formula will be applicable? Since originally this function was not algebraic and non-homogeneous, then x del u by del x plus y del u by del y is equal to n hu by h dash u. Yes, so n is 1 here and hu is nothing but eu, e raised to the power u, and h dash u is again e raised to the power u. So answer is 1 here. Okay, so 1 is the right answer. So this was the last question. I will start integral calculus in the next lecture. Okay, till then keep preparing. Thank you.